Hello, algebra students. We're going to spend this lesson learning about graphing inequalities. Hopefully this will make more sense to you at the end of this lesson, or this is a lesson that can be used to tune up what we learned in class for you, an opportunity to take some good notes. So let's take a look at the prerequisites are knowing how to rearrange formulas, especially ones that are written as inequalities, and how to graph equations, so graphing equalities, things in y equals mx plus b form. So let's take a look at what we're going to learn. Okay, so we're going to learn how to graph inequalities. So these are inequalities, inequalities, right? An inequality, because it has a not equals, kind of a not equal sign. This, on the other hand, is inequality. Quality. Okay, so let's look at how we deal with graphing inequalities. But let's start by graphing the equality. So let's just kind of change up our color here, and whoops. Come on, let's do it right on the line. Okay. So let's just look at this equality, and maybe, so let's just make a t-chart of the equality. So if we know that, x and y, so we have 0, 0, 1, 1, 2, 2, 3, 3. Hey, I know what this looks like. This looks like a straight line that goes through the origin. Something like that. Let's just bring that 1, 1, 2, 2. Well, kind of extend it on down. So that's a straight line that looks like this. And we have 1, 1, 2, 2, 3, 3. These points are all on there, 5, 5. It's not a perfect line, I apologize. But we know what the equality looks like. And so we know that every single point on this line will exist. These are equivalent, right? Every number that fits, and so are these. These are also equivalent. So every number that makes this true, y equals x, is also represented in this t-chart, and everything that could exist on this t-chart exists on this line. And so that's the whole idea of graphing inequality. We have an infinite number of answers. They go on to infinity and beyond in both directions, and 3 different ways of representing the same thing. Now let's look at inequalities. Let's make a list of numbers let's make these in kind of this color here. And let's just call that y is greater than x. And we'll just come back here and we'll say, well, that's y is greater than x. And we'll put everything in this color. So these are, right, this y is greater than x, and this is x and y. So, realize that this is a little bit backwards because these terms are flip-flopped up here. But if y is greater than x, then let's say, well, y is greater than x. So y is greater than x. So let's just make our y is greater than x. Let's make some negative numbers, like 3 is greater than -2. Let's make y have a -1, and that's greater than -3. So all of these points make this true. Y is greater than x. So we're looking at, and let's look at it relative to this line. I'm kind of giving you the hint here, something that people have already figured out, but using this line can help us identify not just these points, but even more points. So let's graph these points and see if we can see a commonality between them. Here's 0, 1. Here's 3, 4. Here's negative, 3, 4. -2, 3. And then -3, -1. And this is 0, 1. Okay, interesting. You might start to see a pattern here. So let's now look at y is less than x. Let's see if we can make some sense out of that one. We'll do these ones all in red, dark red. So this would be y is less than x, or equivalently, x is greater than y. Right? This is x is greater than y. Same thing. Y is less than x. X is greater than y. Synonymous. So if x is greater than y, then we'd have like 4, 0. We'd have like -1 is greater than -3. We'd have 0 is greater than -2. And then we'd have 6 is greater than 2. So let's graph these guys. 1, 2, 3, 4, 0. -1, -3. 0, -2. And then finally 6, 2. Whoops, that's 6, 2. So what can we notice about everything where y is greater than x, and then everything where y is less than x? Well, if you identify that everything here is below the line and everything here is above the line, you would be right. Above and below. So the interesting thing about inequalities, and I'm not going to prove it, formally prove it for you, but it's all on the same side of the line. So we have a line. So the summary is, we'll do this in green. It's like on the line, y, the left equals the right. And in this case, that's y equals x. And then we could say on one side of line, we get the left is greater than the right. And so that's y is greater than x. The left side of the equation is greater than the right side of the equation. And then on the other side of the line, the left side of the left side, we'll just say the left side is less than the right side. So y is less than x. Okay, so that's the punchline. So whenever we're graphing an inequality, we're looking to graph it as if it were an equality, and then we're going to look and see, hey, everything on one side of the line will make it either less than or greater than. Okay, and so that's the point of this exercise. So let me now show you more formally how we represent this. So if we were to say y is less than x and it was everything on this red side, we would simply shade this side. And we would say that's where y is less than x. That shading represents every single point that is on this side of the line. Okay, now I want to give you, now that we've learned how to do this, we're going to have a more formal method for graphing inequalities. And let me do that for you now. So we'll make a new page, and we're going to formally graph using a set of steps that you can write down. So the steps are, 1, we solve for y. This is how to graph an inequality. We solve for y, then we identify whether we are graphing less than or greater than, and in this case we're going to use a dashed line. If we use a less than or equal to or a greater than or equal to, we are going to use a solid line. I'm going to explain this more in a little bit. 3, then we just graph line as if it were an equality using the dashed or solid line. And then 4, we determine which side of line needs to be included and shade that side. To do this, we often test, or we will test one point to determine, we're going to test one point to determine which side to shade. Okay, so those are our 4 steps. Now, if we go back to our prior picture here, whoops, what did we do? We lost that last picture. Frustrated by that. Okay, so let's graph this equation. 2x plus y is equal to is less than -3. Okay, so we're going to follow our steps as we have on the right side, and I'm just going to maybe colorize each step. So let's colorize, colorize step 1. We're going to solve for y. So we want the y on the left. We want y on the left. And everything else on the right. So we have our 2x plus y is less than -3. So we're going to get rid of everything on the left that's not y by subtracting it. So these cancel. So we get y is less than -2x minus 3. So now we've finished step 1. So now we simply got to identify whether we are graphing less than or greater than, and now we're going to use a dashed line. So that's all we do in step 2. We're going to say we use a dashed line because it's a less than problem. Let's not call it a problem. Let's call it an inequality. Let's not call it a problem. We'll call it an inequality opportunity. Let's call it an opportunity. Funny. Okay, so we're going to use a dashed line. Now we're already on to step 3. See how easy these are? Step 3. So now we're going to graph it as if it were an equality using a dashed or solid line. And we know we're using a dashed line. So we have -2x minus 3. So we're just going to graph it as if it's an equality. So we're just going to write y equals -2x minus 3. Now when we graph these, remember, we go to our y-intercept. Our b is -3, and our m equals -2, which is the same thing as -2 over 1. Which is our rise over our run. So we're at -3. This is a point on our line. So now we rise -2, which is down and over 1. down to over 1. And we can actually go backwards now that we see the pattern to build our straight line. So we know we've got to do a dashed line. So remember that we need to do a dashed line. So we're going to do this line that goes like this, 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 this. There's our dashed line. Okay. So now remember, this line represents y equals negative 2x plus 3. That's what that represents the line. But we don't want the points where y equals negative 2x minus 3. We want it where y is less than negative 2x minus 3. So now we're going to move on to step 4, which is where we decide, number 4 is our shading. So we need to figure out whether points on the left line. So the question is do points on the right or the left make our inequality true? And we actually only need to find one. So if we find any point over here on the right that makes it true, then we know that we're shading over here. However, if we find a point on the left side that makes it true, then we're going to shade everything on this side. Because it is the case that if one point on one side works, then every point on one side will work. So I'm going to suggest using the origin, 0, 0. And now we have to say, if this point is true, then all of these are true. But let's look at that. Let's try 0, 0. And so we're going to plug 0, 0 into our equation. And we're going to say, well, y is less than negative 2x minus 3. So if I plug 0, 0 in, I'm going to say, is 0 less than negative 2 times 0 minus 3? So is 0 minus 3 is negative 3. Is 0 less than negative 3? And the answer is no. So this doesn't work. So this side, this does not make it true. Does not. 0, 0 does not make inequality true. So we're going to shade the other side. We know that we need to shade this side, and then we have our answer. But just for fun, let's make sure that we're not crazy, and let's pick this point here. Let's make sure we know that these points on the right side don't work, so these points on the left side must work. But let's just verify that. Let's use this point, negative 3, 0. Let's test. Negative 3, 0. Okay, so y is less than negative 2x minus 3. So 0, negative 3, 0. So our y is 0. Is 0 less than negative 2 times negative 3 minus 3? So is 0 less than 6 minus 3? Is 0 less than 3? Yes, it is. So the point negative 3, 0 does work. And that also means that every point over here will work. And so that's how we answer our question. We have graphed our inequality. Now, notice that because we have a dashed line, that means that the line doesn't make it true. Any point on the line is where y equals negative 2x minus 3. But we can't have that, so that's why the line is dashed. That means we don't include these points. So dashed line means line is not included. If it were a dashed line, we would, if line, we're just gonna, we'll make our last summary. If line were solid, we would have graph of what? We would have a graph. Who can actually jump to the final conclusion? It would be y is less than or equal to negative 2x minus 3. Because that would mean everything over here is less than, and then the line is equal to negative 2x minus 3. So let's just go, oh, happy pig. Oh my goodness. No, happy cat. We're going to stick with our happy cat, and we're going to say bye-bye to you, happy cat. And we're going to come back here to our video, and we're going to sign off. Thank you very much. We'll talk to you, see you in class.